Hello students, Ms. Slyman here with your 6.4 notes on the inverse function. This warm-up you'll have done already, so you should have that in your notes. So inverse functions. You've actually been seeing inverse functions your whole life. Addition and subtraction are inverse functions. Multiplication and division, those are inverse functions. But now we have a technical definition using function notation. So two functions are inverses. This IFF is not a typo. IFF means if and only if. So let me highlight this. So this means let's see if it's going to let me type. Maybe not. All right. So that's if and only if. So two functions are inverses if and only if both f of g of x is equal to x and g of f of x is equal to x. Now remember in 6.3 we said that f of g of x does not equal g of f of x, but in this case, this is the one case where they do equal each other. So given a function f of x and its inverse, if it exists, so inverses do not always exist, we use the notation f inverse of x. So we have an exponent of -1. This does not mean, so f inverse of x, this does not mean 1 over f of x. If we want 1 over f of x, which is normally how we think of our inverse exponent, that is this, the whole thing raised to the -1. That's 1 over f of x. So note, if it's between the f and the x, that means the inverse. All right, so there's our definitions of what an inverse is. Let's look at some examples. So here's f of x is equal to x minus 1 over 2. The inverse is going to be a function where I take this function, put it in, and get out x. Well, inverse also means the opposite. So if I think of what's happening to x when I put it into f of x, so first I subtract 1 and then I divide by 2. Well, the opposite of that should be to multiply by 2 and then to add 1. So let's test that. So f of f inverse of x would be equal to, I'm going to replace this x with all of this. So 2x plus 1 minus 1 divide by 2. Sure enough, that equals x. So in this case, to be thorough, I would also want to test the reverse. So test f inverse of f of x. And when I test that, I'm going to plug this in, going to plug this in to this equation. The 2's are going to cancel. I'll end up with x minus 1 plus 1. That is also going to be x. So now if I want to test, are these two inverses of each other? Well, I'm going to do the same thing. I'm going to calculate f of g of x. So that's f of 4/3 x plus 8, which is going to be 3/4 of 4/3 x plus 8 plus 6, minus 6. Those are going to cancel. That's going to leave x. Plus 6 minus 6 is x. That's good. G of f of x. G of 3/4 x minus 6, 4/3 times 3/4 x minus 6 plus 8. That's going to give me x minus 8. Cancels, multiplies, gives me minus 8 plus 8 is x. So yes, they are inverses of each other. All right. Show that f of x is its own inverse. Well, that implies that f of x is going to equal 1 over x. So if it's its own inverse, it will. So this is our question mark. So let's look at that. F of x, that's f of 1 over x. 1 over x does equal x. Therefore, f of x equals f inverse of x. So it is its own inverse. All right, so I'm going to stop this video here, and in the next one, move on with example 4.